Good morning, everyone. I am Mr. Ish. Thank you for joining me. If you are asked to evaluate this specific equation you have right before you, minus y squared plus 4y plus 6x minus 10 equals 0, and you are told that it is an equation which represents a conic section, the fact that you have a single variable here with a square, that is y, you know you're looking here at a parabola. It could have either been an x square in this equation, or it could have been either the y square in terms of a variable, but not both. The fact that you have only one variable in terms of a square, exponent of 2, tells you clearly that it is a parabola. The fact that the y variable is squared tells you it's either a right or a left facing parabola and not an up or down facing parabola. If you want to start determining what this parabola looks like and all the elements of this parabola, you have to complete the square first. You can isolate that minus and then you can start from there. The minus is isolated from that y square, and then you have y squared minus 4y. We're trying to convert this into now in this form of a parabola. Y minus k whole square is equal to 4p into x minus h, because this represents a parabola which is either right or left facing, but it is indeed a conic section parabola, and that's our goal. We have to convert this into this, so let's do it. Now we have to do the completing square technique right in here. We'll have a y squared minus 4y, and you know 4 divided by 2 and square that, you'll have a plus 4 is equal to minus 6x plus 10. This plus 4 which we've generated multiply with a minus and goes on the other side as a minus 4. What do you end up having? Y minus 2 whole square is equal to minus 6x plus 6. Take the minus on the other side. You have y minus 2 whole square is equal to 6x minus 6. Now isolate from right here. We have y minus 2 whole square is equal to 6 parentheses x minus 1. Now it's kind of taking the shape of exactly what I was hinting to you. Y minus k whole square is equal to 4p into x minus h. I have an x minus h, I have my y minus k whole square. I have to convert this into 4 and p, and I can do that. 6 comes in terms of a 4 and a p. How? Well, you'll bring out a 4 and you'll have a x minus 1 over here, and you have a y minus 2 whole square. Remember 4p x minus h. That's what we're trying to get it into, 4p x minus h. I got my 4, what's my p? This and this should multiply and give you that 6, and you know what it's going to be. It's going to be 3 over 2. That's exactly what it will be. 3 over 2 times 4 will give you a 6, and there's my equation. From this equation you can determine a good amount of items. You can determine the vertex. The vertex is always h comma k, and you know that. And now look in terms of the sign. You have a positive over here, so you know you're looking here at some sort of right facing parabola, but we haven't determined what the vertex is, but it's going to be right facing. X minus h and y minus k. My vertex here is 1 comma 2. Vertex is 1 comma 2. What's my p value? The p value is exactly what you see over here, 3 over 2. So now we're getting a good idea of what we have. We have a right facing parabola. We will do a rough drawing only because it will help us orient ourselves to get the other items we need. 1 comma 2, 1 and then 2. You have a line of axis over here. What's your line of axis? I'll put that right here. Line of axis or line of symmetry. It will be horizontal line y is equal to exactly 2 right here. Y is equal to 2. You'll have a parabola which will look something like this. I'm not being accurate here in terms of depiction. I'm just giving a rough idea. Because the p value is 3 over 2, we know the focal point must be within the u, within the curve of the parabola. The directrix must be on the opposite side and equal distance away. The focal point must be equal distance away from the vertex, as is the directrix. So let's do the focal point determination. The focal point determination is this way towards the right from 1 comma 2. So you're going to do 3 over 2 plus that 1. And you know what that is going to be. It will be 1 plus 3 over 2 comma 2, which is what? Your focal point here will be 5 over 2 comma 2. This right here is 5 over 2 comma 2. Let's do our directrix. It's going to be a vertical line. X is equal to, but it's going to be 3 over 2 units to the left of that 1 value. 1 minus 3 over 2. Remember, it's always the p units. In this direction you have a p units, and in this direction you have p units towards your directrix. What's 1 minus 3 over 2? It's going to be minus 1 over 2. X is equal to minus 1 over 2 is my directrix. So let's clean out some of this mess over here. We don't need to show this. X is equal to minus 1 over 2 right here. Here's my directrix right over here. What else remains to be determined? Well, we need to have the endpoints of this lattice rectum. It would be good to determine the lattice rectum. And how can you determine the lattice rectum? Well, you'll go back here to your equation right here. You can either utilize this equation right here, or you can use this equation. You're looking at relatively the form of equation where you are close to your finalized conic section parabola equation in the standard form, and this right here is a standard form. But again, you can use either of these. You're always going to solve for the squared component, which is y. You're going to solve for y. That means you have to determine what you'll put in place of x. The latus rectum is that segment which goes from one point of your curve to the other point, but always to the focal point. So therefore, you're going to look at the x value of your focal point, and you're going to put that right here. What's the x value of my focal point? It's 5/2. This 5/2 is going to come right over here. So let's find our latus rectum points. Y minus 2 whole square is equal to 4 times 3/2. Let's just do 6. We have 5/2 minus 1. What's 5/2 minus 1? It's going to be a 3/2. So let's do this. It's 3/2. What's 3/2 times 6? Well, this goes right here. 3 times, you end up having a 9. So y minus 2 whole square gives you a 9. That's exactly what you're getting. Now you're solving for this y. Y minus 2 is equal to the square root of 9, which is plus and minus 3. Y is equal to plus and minus 3 plus 2. But what are these values? 3 plus 2 is a 5, and minus 3 plus 2 is a minus 1. These are your y values of your latus rectum. One right here and one right here, but they'll have the same x value as the focal point, your latus rectum endpoints, and that's exactly what we're determining. And I'm going to squeeze them right over here. I'm going to abbreviate. Latus rectum endpoints are going to be exactly 5/2 comma minus 1 and 5/2 comma 5. These are my latus rectum endpoints, and you see them. Here's my 5/2 comma 5, and here's my 5/2 comma minus 1, and these points have been completed for you. And remember, to determine the latus rectum endpoints, you're always looking at your basic conic section parabola equation, and you're solving for that squared variable component. If you had a y over here, you would have picked the y value from your focal point. If you have the x variable here, you put the x value of your focal point, but it's always a focal point value which comes in here, because the latus rectum always goes through the focal point. Anyhow, there are two tests you want to use now to make sure your answers are right. Test number 1, the focal point is always the midpoint of your latus rectum. You take your latus rectum, you find the midpoint of it, and that should be exactly this. What's the equation for a midpoint? You know it's always x1 plus x2 over 2 comma y1 plus y2 over 2. That is your formula for a midpoint. Look at the latus rectum and determine the midpoints. 5/2 plus 5/2 divided by 2 is just a 5/2. No deviation there. But now look at this. Minus 1 plus 5 is a 4. 4 divided by 2 is a what? It's a 2. What is your focal point value? It's 5/2 comma 2 and 5/2 comma 2. So we're right. Our focal point is good. The latus rectum endpoints are good. But that's only one test. The test number 1 I just talked about was that the focal point is always at the midpoint of your latus rectum segment. What's test number 2? Test number 2 is this. The length of your latus rectum is always equal to 4 times your p-value. The length of latus rectum segment is 4 times your p-value. How can I determine the length of this latus rectum? Well, you can use a distance formula. But look over here, there's no change in the x value. You know the distance formula, the square root of y2 minus y1 whole square plus x2 minus x1 whole square. The x1 and x2 have no change, so they'll be 0. You're only doing now the segment utilizing the y value is 5 minus minus 1 is a 6. You're doing that. Y2 minus y1 whole square, 5 minus minus 1 whole square, and root. The x values here are irrelevant because there's no change in that. You have a 6 square, which is 36. Root of that is 6. So you're having a segment of 6. And then I'm telling you 4 times the p-value should always equal to length of your lattice rectum, and that's true. 4 times my p-value is always equal to 6, and that's exactly what you see right over here. And so we're good. Our lattice rectum segment in terms of its length is 4 times the p-value. The lattice rectum in terms of its midpoint is equal to the focal point, so everything here looks right. At the end, this is what you present. This right here is your finalized equation of this parabola facing towards the right in standard form. Y minus 2 whole square is equal to 4 times 3 over 2 x minus 1. You have a vertex which is 1 comma 2. You have a p-value 3 over 2 plugged out from right here. You've plucked it out. Your line of axis or line of symmetry is y equals 2 because it's a right facing or left facing parabola. They'll have a horizontal line of axis or symmetry. Your lattice rectum points are 5 over 2 comma minus 1, 5 over 2 comma 5. You have a directrix here which is x is equal to minus 1 over 2. You have a focal point which is 5 over 2 comma 2, and everything checks out. And that right there brings us to the completion of this particular video. Remember, I presented a video, I believe 1 or 2, on the basics of conic section parabolas where we didn't bring translation into the picture, but here we have translation. Remember, you know you have translation into the picture when you have the form of y minus k whole square is equal to some p-value times x minus h. The minute you start seeing h and k representations in your equation, you know you have translation at play. And this right here is an example of a parabola with a translation at work. And that's it. Thank you for watching this video. Have a good day.